Then you have the inequalities that feature or and to work with. Now, we'll focus on, let's see, this one right here. Okay, let's say you've got a number line. Your critical values are 2 and 3. And what I'll do is I'm going to represent this with a blue line, and I'll represent this with a red line. So let's focus on the x is greater than 2. Now first of all, we know that since it's greater than, it's going to be an open circle as opposed to a closed circle. And since x is greater than 2, that means that we're dealing with everything from 2 on up, not including 2. And since x is everything less than 3, that means that there's going to be an open circle on 3, and there's going to be everything less than 3. Okay? Now basically, when you're graphing the final graph, and it's an OR situation, you're basically scanning this graph, and you want to basically draw a line that represents the total activity on the graph. Now we know that everything from 3 down is covered, according to this line, and everything from 2 up is covered, according to this line. And since it's OR, you want to graph all the activity that's on the graph. So it would be the entire graph. And that's one of those situations where it is indeed all real numbers. Okay, so that would cover that problem. So let's focus on this one here. Okay, so once again, we'll just simply draw a number line for now. We have the same critical values, 2 and 3. But now, x is everything less than 2, and x is everything greater than 3. So we'll do that open circle above 2. And since x is everything less than 2, it's going to go that way. And then we're going to do an open circle above 3. And since x is greater than 3, it's going to be everything going that way. And the final graph is, once again, since it's an OR situation, you're representing all of the activity that was represented here, and that would be open circle, and this way, and this way. And that is not all real numbers. There is clearly this kind of split in between them. Now this is pretty common. When you have an OR, it's very common that you're going to have a split in between them like that. And like you mentioned very intelligently today, when there is an intersection and it's an OR, then it's all real numbers. Okay, like that. When there's an intersection and they're both facing in opposite directions, then it's all real numbers. And that actually reminds me, I'm going to give us a third situation too for the OR. What if instead of these two, we had something like x is greater than 2 or x is greater than 3? Now that is a little bit different. But the process is the same, at least in the beginning. You've got the number line. You've got your critical values of 2 and 3. And I'll color code it like I did with the other ones. That's blue. And that's red. So let's go ahead and graph this. So x is everything greater than 2. So once again, that's the blue open circle. And that means that we're dealing with everything greater than 2. And then we have the red open circle above 3, and it's everything greater than 3. Now when you do the final graph, once again, if you're dealing with an OR situation, you're pretty much representing where on this entire graph is the activity or the action happening. Now if you notice, everything to the left of 2, there's nothing going on over here. So we're not going to draw anything over here. All the action is like right here. Okay, now since the action begins at 2 and then moves to the right from there, in our final graph, that's what we're going to represent. An open circle at 2 and everything else above that. Okay? Once again, since it's an OR situation, we're paying attention to where the action is on the graph, and the action begins here and it goes on forever in that way. So since there's all kinds of stuff happening from 2 on, we're actually going to go ahead and just draw the final graph such that it goes from 2 on. So what I'm trying to say, in other words, is we're going to disregard this open circle, because this open circle may suggest that x is greater than 3, sure, but remember, 3 itself is included in this solution set. Why? Because x is also everything greater than 2. Alright, and 3 is greater than 2, so that's ultimately in the graph. Okay, so once again, when you're dealing with OR, you're just paying attention to where is the action on the graph. There's nothing here. There is stuff going on here, so we're going to take that into account in our final graph. Alright, so that's that stuff. I'll put this off to the side, and I'm going to make this guy smaller. Let's see if I can fit it kind of in there. Alright, so then we have the AND situations. And the AND situations are quite different. And I think probably the best thing to take away from today's session is that the AND, it really has ultimately to do with the intersection of these lines. So, focusing on the first one, we've got a number line. We've got our critical values of 2 and 3. We will, again, color code it, make it a little easier. Now, x is everything greater than 2, so we have that open circle in 2, and we have an arrow up there, going like that. And x is everything less than 3, so we have an open circle above 3, and then everything down below. Now, since we're dealing with AND, we're focused only on the intersection. Now the intersection occurs here. This is the moment where there's 2 lines stacked above each other. So when you're doing the graph, you're going to want to represent that. You have an open circle here and an open circle there, and it's everything in between. Like that. Okay? Because it's only this space. It's only this space right here where there is an intersection. Notice how the intersection does not happen on these open circles. There's no intersection happening on these open circles because this is open. Sure, there's stuff going on here, but this is open, so this does not intersect with that. Sure, there's stuff going on here, but this is open, so this is not an intersection. Therefore, we preserve these open circles and we focus only on the intersection. Okay, the place where the 2 lines are actually stacked one on top of the other. It is often the case that AND inequalities will lead to this intersection where it's like a line segment, like that. Okay, so that's that. And we'll do a little divider right here. Alright, and finally you have this situation where you have x is less than 2 and x is greater than 3. We'll draw a number line. We have 2 and then we have 3. X is everything less than 2, so we're going to draw the open circle and we're going to have it go that way. X is everything greater than 3, so we're going to draw the open circle above 3, and everything going that way. Now, as you can see clearly, there is no intersection. And since it's an AND problem, when there's no intersection, that means there is just no solution. Because there's no intersection, and it's an AND problem. So that's when you get the no solution situation. Alright, so that pretty much covers a lot of what we did today. I think the only thing I could say that you need to remember is be careful on the test because there might be some underlines underneath this stuff. And of course, when it's an underline, then you have to go ahead and just do the closed circle thing. You know what I mean? Like that would be closed and that would be closed if there was an underline under there. Okay, so just to keep that in mind. Similarly, if this was an underline, then x is greater than or equal to 3, so that would be a closed circle. But guess what? It would still be no solution in this case because there's no intersection happening. Alright, so hopefully that's clear, and stay tuned for the next video.